So far, we talked about how you can using the invoke to call the procedure and passing the parameter. But one thing I want to remind you and be careful about that. Because just like we passing the parameter, when you call the invoke, the compiler didn't really will check the specific data what you are passing, as long as their data size match. So here, when you're using the invoke, remember you can specify you want to pass a D-word value, or you can specify to pass a reference. In C++, we understand your data value. You have the int, double, but also you have the int pointer or double pointer. So that's why they specify these two different data type. But if you understand that, so let me write down here. So in C++, remember int is 4 byte. Your double actually is 4 byte as well. But in C++, we understand int and double, they are two different data. And if you have int pointer actually in 32-bit environment, they are 4 byte as well. In C++, we do have these two different type. You can be int value to passing by value, or you can have int pointer passing by reference. However, in assembly language, they are different. For example, here I want to passing a first value is D-word. So D-word is what? 4 byte. And I can say I want to passing by array reference. So this array reference, I will write that's a byte array. So that's the PTR byte. But here, when you say you want to passing by reference, this one is what? It's 4 byte. Right, so even we know passing by pointer, passing by address, or passing by a value, they are different. But in Mason, they don't understand that. When they see that, they only consider I will read 4 byte. So that's a little different than the high-level language. So that's why when we say you need to call invoke, you need to really careful when you're passing a pointer to the correct data type. So that's one thing is when you have, I'm expecting a byte pointer, but if you give me a data value is D-word, when they see the 4 byte, they just treat that as a 4 byte. Or you say here, you have another array, you want to have D double word array. So you say the PTR is D-word. But the same thing, you see, even you say you want to have a double byte array, double word array, but as long as they are a reference, in 32-bit environment, they are all 4 byte. So that's why Mason, they not really can distinguish what's different between these two data reference because they are all memory location. It's different from in C++, right? C++, we understand that's a double. Because in C++, we know pointer is reference. But when you say double, I will read from using that location to read for how many bytes and how we will treat them. So that's why Mason cannot distinguish between a D-word argument or a PTR byte argument because what they care is the size only. So you need to really be careful. And also do not passing an immediate value to a procedure that expects a reference parameter. So that's this one, the same thing. Okay. So if you passing, you invoke, then procedure, you give them 5. Actually, they kind of using treat the 5 become address. So kind of you don't have the error, but you will have runtime error. So that's when you're using the invoke. Be very careful. That's different from the high-level language. So continue. The next example I want to show you is in Write32 library, they have a WriteStackFrame procedure. So what is the WriteStackFrame? Sorry, because earlier we talked about when we have a procedure, so now you can pass in the local variable. You can specify local variable. You can pass in the parameter list. They are all showing in the stack frame. So that's why here on Irvine 32, they will picture the stack frame, how they contain the value for you. So you can invoke a WriteStackFrame. So that's their prototype. WriteStackFrame, they are expecting 3 double word value, but actually they just a number. So the first thing you can tell them how many parameter you have, how many local variable you have, how many safe ranges you have. So remember, you see these 3 parameter, local variable, and safe ranges, they are all inside the stack frame. So after you have those information, so then when you call your procedure, inside your procedure, you also call your WriteStackFrame. They will display your stack frame like this. Okay, so they will show you here is the EBP. So up to the EBP, that's those value. And also that's those value for. So remember, here you have push EBP. You see, even after you using the PROC directive or local directive, you don't really need to manually push or pop EBP, but in your stack frame, you still have EBP. So you see here is our base EBP. So before that, you add the value. They are return address and the parameter. So you minus the value is your local variable. So that's why here you can see if you have local variable and you have regist, the local variable will be before your safe regist. So here you see that will also show you where is the current ESP. So this one actually you can see we have this example. Your main function, you just try to invoke a procedure we call approc. So this approc, you can see you invoke that, you pass in 2 value. That's why we need 2 parameter list. So that's why in our approc, so they're using EAX, EBX, they need to push and pop and save the EAX, EBX value. So then here you can see the XY is your passing parameter. So then you have your local variable A and B. So that's why inside your procedure, when you call that, if you want to see how your stack frame look like, inside your procedure, you can invoke WriteStackFrame. So here you can see the parameter and the local variable number and the safe ranges, they are all 2. So here they can have the value like this, the constant value, or you can just give them the instance value. So that's why we will see the output like that. So you can check the result. So in your demo file, I give you the test_WriteStackFrame.asm file. So this one actually you can also get from the Irvine directory under the chapter 8. So in this example, they have many different procedures. You see they have the A procedure. They have 2, they need 2 registers and 2 parameter lists and 2 local variable. So inside here, they call WriteStackFrame. So then you see here you have the B procedure. So this B procedure actually they don't really have any local variable and the parameter and the saving regist. And you have the C procedure. So actually this one is an invalid example. They only have the EAX and EDX. So then actually they don't using the uses, but they didn't give you the parameter list. So that's why in the code they manually push EBP. So those kind of procedure, when you call the WriteStackFrame, they will be invalid because when you can call the WriteStackFrame, they want you to using the parameter list passing to the procedure using the invoke. So then you have more example, we will all show you the result. So that's why here in the main function, you see we call procedure A, B, C, D, E, and you have F, G, H. But then when you run the program, so that's how you will see the output like this. So for me here, I have the A procedure. Okay, so I'm not sure that's big enough. So that's why you should try on your system to see the result. Download this example so you can have a B. Yeah, you see here you only have, they have no local variable, no parameter, no register. So that's why you only have the return address. So they still have the EBP. So then you see in the stack frame for the C procedure, so they are not really a true stack frame because they're using the register, but don't have any parameter and local variable. So that's why they did using that in the push EVP in the code. So that's actually is not correct one. So then you can see here for each different procedure how they will show the stack frame in there. So the last two actually, when you do the code procedure, the same thing, your stack frame actually is invalid. Okay, so check example one by one. So hopefully this one will help you to understand what is the stack frame when you call a procedure.